Picture two people who agree on almost everything. They share a language, a watch brand, a definition of the second down to the vibrations of a cesium atom. They stand on the same platform and shake hands, and in that instant they would both swear they inhabit the same present, the same universal moment, one that contains the handshake, the distant city, the far side of the moon, and a star 1,000 light years away, all of it existing together in a single slice of time called now. This conviction is so deeply built into human experience that it feels less like a belief than a fact of nature. And it is precisely this conviction that physics, over the course of the 20th century, quietly revised. The finding was not announced with fanfare. It arrived as an unavoidable consequence of how the universe behaves, and it is this: there is no universal now, no single present moment shared by every observer everywhere. The universal present that seems to hold the whole cosmos together turns out not to be a feature of the universe in any observer, independent sense. It is a feature of a point of view. To understand how something so fundamental could come apart, begin where Einstein began, with light and its strange refusal to behave. By the closing years of the 19th century, physicists had measured the speed of light with extraordinary precision and stumbled into a contradiction that should not have been possible. Every inertial observer who measured the speed of light in a vacuum found the same value, regardless of the motion of the source or of the observer. This is not how anything else behaves. A ball thrown forward from a moving train travels faster, relative to the ground, than one thrown from a standstill. The train's speed adds to the ball's. Light alone ignores this rule. Shine a beam from the front of a train, moving at half the speed of light, and an observer still measures that beam receding at exactly the same speed it would have if the train were parked. Every attempt to find a frame in which light slowed down or sped up failed. The speed of light was a constant for all inertial observers, and that single stubborn fact, taken seriously, was enough to undo the idea of a shared present. Einstein's genius in 1905 was to refuse the obvious escape routes, and instead ask what the world must be like if the speed of light truly never changes. He realized that something would have to give, and the thing that gave was the assumption that everyone everywhere shares the same time. Consider what it actually means for two distant events to happen at the same moment. To call them simultaneous, you need some way to compare their timing across the distance between them. But any signal used to make that comparison can travel no faster than light. Einstein worked through how one might synchronize two clocks separated in space, sending light signals between them and accounting for the travel time. And he discovered that the answer depends on how you are moving. Two observers in motion relative to each other, performing the synchronization with equal care and identical methods, will disagree about which distant events count as simultaneous. Not because one has made an error, but because, in relativity, simultaneity is not absolute. What counts as happening now in one frame of motion can count as past or future in another. The cleanest way to see this is to climb aboard a thought experiment that has survived more than a century of scrutiny. Imagine a train car moving smoothly along a track, and at its exact center a lamp that flashes once. Inside the train, a passenger watches the light spread outward in both directions. Since the front and back walls are equally distant from the lamp, the light reaches them at the same instant. For the passenger, the two walls are struck simultaneously. Now consider someone standing on the platform as the train rushes past. For this observer, the light still travels at its fixed speed in both directions. Yet during the time the light is in flight, the train moves forward. The rear wall advances to meet the oncoming light while the front wall draws away from it. After accounting for the time the light takes to travel, the platform observer concludes that the rear wall was struck before the front wall. This is not a trick of delayed images reaching the eye. It is the considered judgment of when the events actually occurred in that frame. Two events that are simultaneous for the passenger are, for the bystander, genuinely sequential, one earlier than the other. Both accounts are correct within their own frame. There is no third privileged vantage point from which one could be crowned the true one. The order in which distant events happen, the very question of what is happening at the same time, has come unmoored from any single answer and attached itself to the observer. If this disagreement were confined to trains and laboratories, one might dismiss it as a technicality too small to matter. But the logic scales without limit, and applied to the vastness of the cosmos, the consequences become genuinely vertiginous. The physicist Roger Penrose framed the implication with a now famous illustration offered explicitly as a thought experiment rather than a literal claim about events. Imagine two people walking past each other on a street, strolling in opposite directions at an ordinary pace. Because simultaneity depends on motion, their definitions of now extended across space to the Andromeda galaxy, more than 2 million light years away, do not coincide. The difference in their walking velocities, trivial as it is by everyday standards, is enough that their slices of the present, stretched across that enormous distance, diverge by days. A distant event in Andromeda could fall within one person's slice of the present, while lying in the other's past or future. Both people stand on the same pavement at what each would call the same moment, and yet they're two versions of the cosmic present, cut through that distant galaxy at different places. The point is not that the galaxy is doing two contradictory things at once. It is that the very notion of which distant moment counts as simultaneous with the handshake has no single, observer, independent answer. This is the quiet revision. The everyday now, the universal instant that seems to slice cleanly through all of existence, turns out to behave like a horizon, something that genuinely appears from where you stand, but does not correspond to a line drawn on the landscape itself, move differently. And it tilts. Two observers in different states of motion carry with them different planes of simultaneity, different slices through the same reality, each convinced it has captured the present. Relativity does not single out one of these slices as the real one. They are perspectives on something larger, and it is here that physics offers a way of picturing that something larger, though it is important to be clear that what follows is an interpretation, not a settled fact. If different observers slice time differently, and if the theory privileges none of these slices, then one natural way to make sense of reality is to stop thinking of it as a fleeting present flowing from a vanished past into an unwritten future, and to think of it instead as a complete, four-dimensional whole. In this view, often called the block universe, all of time exists in something like the way all of space exists. The past would not have vanished, and the future would not be absent. They would simply lie elsewhere along the time dimension. As real as distant places are real, even when you are not standing in them. Your birth, this present moment, and your death would all be features of the same unchanging structure. The flow of time, the powerful sense of the present racing forward, would in this picture be more a feature of how consciousness moves through the structure than a property of the structure itself. This interpretation fits relativity comfortably, but it remains a matter of ongoing philosophical and scientific debate. Other physicists and philosophers read the same equations differently. Einstein himself leaned towards something like this view. Writing to the family of his lifelong friend Michel Besso after Besso's death, he offered words that reflected the way he had come to understand time through his physics, observing that for those who accept the theory, the distinction between past, present, and future is a stubbornly persistent illusion. The line was personal and philosophical as much as technical, but it grew directly out of how relativity had reshaped his thinking. That sentiment deserves to be handled with care, because it would be easy to overreach. Relativity does not claim that time is unreal, or that change is a fantasy, or that nothing truly happens. Events occur in a definite order along any single observer's path through the universe. The relativity of simultaneity does not let you scramble cause and effect, or remember the future. If one event causes another, every observer without exception agrees that the cause came first, because the influence between them travels no faster than light, and that ordering is preserved in every frame. The structure of before and after is protected wherever it actually matters, wherever one thing can influence another. What is not protected, what dissolves under examination, is the idea that this ordering extends into a single universal sheet of present moments stretched across all of space at once. The thing relativity removes is specifically the cosmic now, the imagined instant that would let you speak meaningfully of what is happening, right, this second, in a galaxy you will never reach. That instant has no observer, independent meaning. It was never measuring anything the universe agrees on. There is a further turn, and it comes not from physics, but from the study of the brain, which has its own quiet revision to contribute. Even the local, personal now that you feel yourself inhabiting at this very moment, is not a simple window onto reality. The sensation of a present instant is assembled by the nervous system out of signals that arrive at different speeds and are processed over different intervals. Sound and light reach you and are handled by the brain at different rates. Yet you experience a person's voice, and the movement of their lips is happening together, because the brain quietly gathers the streams and stitches them into a single constructed moment that is already a fraction of a second, old by the time you feel it. The now you experience is something like an edited summary, a best estimate of what just happened, presented to consciousness, as though it were live. The brain runs a slight delay and hides it from you, producing the seamless present that feels so immediate. So even before relativity reaches out to dissolve the cosmic present, neuroscience has already shown the personal present to be a construction, a useful model the mind builds in order to act in a world that does not arrive all at once. Set these two findings side by side, and the familiar ground softens beneath you. The present you feel is a model built by your brain, smoothed and delayed and presented as immediate. The present you imagine extending out into the universe is a slice that depends on your motion, one that no two differently moving observers will agree upon. Between them, the everyday now is pressed from both directions, the inner and the cosmic alike. And yet the strangest part is that none of this changes how it feels to be alive. You will still experience this sentence as occurring now, still feel the present moving forward, still sense the past slipping behind you and the future rushing up to meet you. This experience is not a flaw to be corrected. It is the very texture of conscious existence, and no amount of understanding dispels it. Perhaps that is the real lesson hidden inside the equations, the one that survives after the technicalities have been absorbed. Physics has not stolen the present from us, so much as it has shown what kind of thing the present always was. It was never a property of the universe, a master moment ticking the same for all. It was always a relationship, a meeting point between a particular observer and the world, real from that point of view if not from any other. The cosmos does not come with a now built in. It comes instead as an immense four-dimensional fabric, and the sensation of moving through it, of standing always at the bright edge called the present, is the form that being conscious inside such a universe seems to take. The universal now was quietly set aside by physics, not because time was found to be false, but because that shared instant was found to belong to the observer rather than to the stars. And there is something almost consoling in that, once the vertigo subsides. The moment you are living in cannot be located on any cosmic map, cannot be shared with a distant world or fixed against a master clock, because it was never out there to begin with. It is yours. It is the universe seen from exactly where you are, and that, it turns out, is the only place a present like this has ever existed.